All right, so let's take a closer look about how to locate the earthquake epicenter using distances calculated from a time distance graph. So for example, in your exercise in your laboratory manual, it's able to calculate the distance from each one of these seismometers in Seattle, Boston, and LA. So each one of these distances is the distance, right, from the seismometer to the earthquake epicenter. But we know that this distance, this radial distance, doesn't really help us locate the earthquake epicenter because this distance could show that it's 2,985 kilometers in any direction, all right, in some radius around Seattle. So in order to actually calculate and estimate the earthquake epicenter, we need data from at least three stations in order to triangulate. Now, in your exercise, you calculate these distances from a time distance graph. So in this case, you would take the lag time between your S wave and your P wave, and you would then essentially estimate out an SP lag time. And then based on your seismogram data for each station in your example, you would then use this, right, based on the time that you get from that seismogram to then calculate what distance it is based on that time. So that's exactly what I've done here for each of these three stations with the example given. So what do we do now? We have the distances, right? We see the location. And what we're going to do is we're going to take these distances and we're going to plot them on this scale. And we're going to use this map scale in order to determine the actual distance from point to point on this graph. So what you're going to need in order to do this section is you're going to need some kind of implement. In this case, I do have a proper compass. If you do not have a proper compass, you can use a pencil or some writing implement with some kind of string, all right? But for ease of this, I'm going to use a compass that I have at home, but a string and pencil also suffices. So let's start by looking at Seattle. So it's 2,985 kilometers. So somewhere around here, just before we hit 3,000. So I'm going to take the pointed end of my compass, plot it on the end of this scale, and then I'm going to take my pencil end and line it up with that 2,985. I'm going to lock that in here. And now I'm going to put that pointed end on that seismometer station, so Seattle here. I am then going to begin to draw out an arc. So that means from Seattle, the earthquake is some X distance, aka 2,985 kilometers in some direction from the Seattle seismometer station. So now I have the data from one station. So now I'm going to do it for the rest. So now we got Boston. Now we'll do LA. All right, so I followed up with a Sharpie so you can see it easier. But now I'm going to look at where the three of these circles intersect. And you can see that they intersect around right here, which is the southeast portion of Missouri and the western portion of Tennessee, which means that the epicenter of this earthquake is going to be right where the three of these epicenter radial distances intersect. So that's how you can locate the earthquake epicenter.